Hello everybody. So today we'll be starting the second module. So we have completed the first module. We'll be starting the second module, module number 2, which is equilibrium of forces, and the friction. It has two parts. Module number 2 has two parts. The first part is equilibrium of forces. The first part is completely concerned with the equilibrium of forces, and the second part is friction. It has two parts. So let us start the first part, which is equilibrium of forces. In order to solve the numericals or understand the concept of equilibrium of forces, you should be comfortable with the concepts of the previous module. Let us start with the concept of equilibrium of forces. This is module number 2. Module number 2. The first concept which comes under equilibrium of force. Let's try to understand the definition or meaning of equilibrium before we start with the first concept. See, let me consider a body. In order to understand the concept of equilibrium in a simple manner. Let me consider a body with a number of forces. Say force F1, F2, F3, and F. So this particular body has a number of external forces acting upon it. Now, so this particular body is said to be in equilibrium. Let us try to understand the word meaning of equilibrium. This particular body is said to be under equilibrium. If the body stays stationary. Even under the application of external forces. Even though you apply a number of external forces on a particular body, and even under the application of external forces, if the body remains stationary, then we call such bodies as bodies under equilibrium. This is a simple meaning, general meaning of equilibrium. So we can call a particular body as body under equilibrium when a body under the application of external forces stays stationary. Even under the application of external force, if the body doesn't move, if it stays stationary, then we call such bodies as bodies under equilibrium. So this body to remain stationary, all the forces should cancel each other. Not all the vertical forces should cancel each other. All the horizontal forces should cancel each other. Or we can write this particular concept in a better way. So all the horizontal forces cancelling each other can be written in this way. Summation of all the forces along x direction should be equal to 0. Right? So all the horizontal forces cancelling each other in order to keep the body under equilibrium. Summation of fx should be equal to 0. Similarly, all the vertical forces cancelling each other can be meaningfully written in this way. Summation of fy equal to 0. And there should not be any rotation as well. Body should stay stationary. That's our main motto. So, moment about any point should be equal to 0. So these are the three conditions of equilibrium. So equilibrium is a condition where body stays stationary even under the application of external force. A body to be under equilibrium should satisfy these three conditions. The first condition is summation of fx equal to 0. Summation of all the forces moving along x direction should be equal to 0. Second condition is summation of fy equal to 0. Summation of all the forces moving along y direction should be equal to 0. And there should not be any rotation. So moment about any point should be equal to 0. These are the three conditions of equilibrium. So this is important. This question is important. We will be asked to define equilibrium and to write the conditions of equilibrium. I hope you understood what equilibrium is. Equilibrium is a state where body remains stationary even under the application of external forces. Even though there are a number of external forces acting on the body remains stationary. And these three are the conditions. Summation of fx equal to 0, summation of fy equal to 0, and moment about any point should be equal to 0. Only if a body with a number of external forces satisfies these three conditions, then we call that particular body as body under equilibrium. This is the concept of equilibrium. Now, you have, these are the three conditions of equilibrium. You have a particular theorem which is called as Lammie's theorem, which can be applied, to find the unknown forces, whenever a particular body is in equilibrium. So Lammie's theorem can be applied only when a particular body is under equilibrium. So let us go through the statement and meaning of Lammie's theorem. Let me draw a particular drawing. This is Lammie's theorem. In order to understand the concept of Lammie's theorem can be applied to a particular body which is under equilibrium, only under equilibrium. So let me consider three forces, say P, Q, and R. So let this angle be alpha, let this angle be beta, and let this angle be gamma. So we have considered three forces. Now, according to Lammie's theorem, or let me just tell you the statement of Lammie's theorem. According to Lammie's theorem, if three forces, Lammie's theorem can be applied for a system with three concurrent forces only. If three forces acting on a particular body or a point is under equilibrium, then each force is proportional to the sign of angle between the other two forces. Each force is proportional to the sign of angle between the other two forces. Now, according to Lammie's theorem, according to the statement here, each force is proportional to the sign of angle between the other two forces. Here, P is one of the forces. P is proportional to sign of angle between the other two forces, Q and R. Angle between the other two forces is alpha. P by sine alpha is equal to Q by Q divided by sine of angle between P and R. Q by sine beta is equal to, I'll write it here, is equal to, the third force is R. R by the sine of angle between the other two forces, sine gamma. So this is the statement of Lammie's theorem. So Lammie's theorem has a small disadvantage or limitation. So Lammie's theorem can be applied for a concurrent force system with three forces only. You cannot apply Lammie's theorem with a concurrent force system under equilibrium, acting on a body under equilibrium with more than three forces. You cannot apply. So Lammie's theorem can be applied for a system with three forces only. So according to Lammie's theorem, each force is proportional to the sign of angle between the other two forces. P divided by sine alpha. Alpha is the angle between Q and R. Q divided by sine beta. Beta is the angle between P and R. R divided by sine gamma. Gamma is the angle between P and Q. So this is all about Lammie's theorem. Hope this is clear. This particular theorem is very, very important. So the application of this particular theorem is to find unknown forces. For example, you know the magnitude of Q and R. If you want the magnitude of P, you can use Lammie's theorem and very easily find the magnitude of P. So this can be applied for a particular system of three concurrent forces, and the body should be under equilibrium where these three forces acting, or where these three forces acts upon. Body should be under equilibrium. So hope this concept is also clear. We went through the concept of equilibrium. Body can be called as body under equilibrium when it stays stationary even under the application of external forces. This is the concept of equilibrium. And you have three conditions of equilibrium. First condition is summation of fx equal to 0. Second condition is summation of fy equal to 0. And third condition is moment about any point should be equal to 0. Basically, there should not be any horizontal motion or vertical motion, or there should not be any rotation. Body should be stationary. These are the three conditions of equilibrium, and this is about Lammie's theorem. Lammie's theorem can be applied for a body under equilibrium with the three external forces. Hope these two concepts are clear. So we'll be discussing the other concepts in the next video. Thank you.